Welcome back everyone, my name is Dustin, and in the last video we created this rain generator. You see the rain in the background here. And these videos are going to be the start of our new game interval. We're going to create a simple platformer game so we can test out our new physics that we just added in. So the goal for this video is to build this where we can get the character moving on the screen, load in the new test map so we can get the colliders created, and also start adding in any new functionality that we need to do. So the first thing we're going to need to do is create a new simple tile map for our test platformer. Since we still don't have our own integrated tile map editor, I created one using the wonderful tiled map editor, this here. So if we take a look at this, all I did was I have 4 different layers. We have our background, we have our platform, we have our colliders, and our triggers. And what I did here is I have just this big background image that I used these images for the last game jam I was in. Then we have this collider, and this is just a simple sprite. It's only a visual for us to see in the tile map editor. We don't care about it once we add it into the game. And then we have our triggers. So basically what we want to do now is change the way that we take these files. So right here, we're going to want to export as. So we're going to export it to our editor, assets, and then our script, test project. Yeah, see, I don't have that there, so I want this test platformer. We already did this test map previously, so let's call it test platformer. Test platformer.lua and export it. So we go into our project. This is where we were last time. We created our rain generator. We want to go into our test project and refresh this. So we have our test platformer. So if you remember from before, tiled will export it here basically as a Lua table. And this whole thing is just returning a table. So we're going to use that as our map depth. So let's create a little function here. So function create test platformer map. Okay. And then go all the way to the bottom and just put end. That's the end of the function. So now that's a function. So now we can load this map. So let's actually just run this from where we have. Right now, we're actually running the old map, and it should just run this here. Cool. You see how it has our rain that we generated last time? All right. So let's just close this, change this here, and let's see if we can run our test platformer map. Platformer. Let's see if that loads. Okay, so we have some errors, and that's fine. Attempt to call create test platformer map. Hopefully you guys caught the reason why. The reason is we're not loading it. So we need to load that in. So test map, test, and we just call this the test platformer. And if we try to run it again, should run. Okay, cool. So we got a bunch of errors here. That's because we stop this. So it doesn't see the trigger textures. So it's trying to do all these textures, but it doesn't see them yet. So we have to add those in. So if we come here to our assets, and then our textures, I already put these things in here, but it's not seeing the trigger. It's not seeing these things. So I already added these. So if we go back into tile, these textures that are embedded in the map, I already added those in to my textures folder. However, I didn't add them into our script. So we go to test project, our asset defs, and we open this up. It still doesn't know about those, and we need to add those in. So we just copy this line and then say collider. Oh, collider's already there. It knows about the collider. We need to say trigger. Change it to trigger. And then we also need to add in, what were the other two? The hill tiles and the background forest. Okay, hill tiles. Hill tiles. And BG forest. BG forest. Cool. If we run it now, it should run fine. Nope, still nothing. So hill tiles don't exist. Yeah, so still didn't see the hill tiles. Oh, Heil tiles. That's funny. My bad. You guys probably caught that as well. Running it. Awesome. So this is our map. The rain was there previously. That's fine. So Now, if you can see, our window doesn't accommodate this correctly, the way that we have it scaled. So now we have to go and make some changes to our utility. So if you remember from the video creating and loading tile maps using Lua, we created a tileset class that parses the data from the generated Lua file into its own little tileset class. If you haven't seen that video, you can check that out right here. Or just grab the latest master from GitHub and open the utilities.lua file, and you can still follow along. So if we go down here, this is where we're loading the map. We're going to have to make a few changes here, okay? So previously, we would load the sprite no matter what, and if it was a collider, we would add a collider this way. If it was using the tileset name collider. So if you come back to tile, so we have our tileset collider and a tileset trigger. We can actually hide these here, so it's not going to show those. All these are colliders. And we want these to actually now, because we have added physics, we want to create physics components with these for those entities. So let's go back. So we're going to want to change this a little bit. So we're going to move our sprite generation down. Let's take this out, bring this down to the bottom. Okay. And we're going to put that here. And we're also going to add in a flag up here. And right before we do this stuff, we want to go local B is collider, and then have that equal false for now. And then down here, if it's not a collider, that's when we'll create the sprite. So if not B is collider, then and move all this stuff over. So if it's not a collider, create the sprite. So if not collider, create the tile sprite. Cool. So we won't need this hidden. If it's a collider, we're going to want to say B is collider and set that to true here. So if the tileset name is collider, we're creating our collider. Let's get rid of this scaled and put it to 2 or put it to 1. Just put scale to 1 for now, so it'll be a 1:1 ratio. We could probably even just get rid of that, but we'll just leave it to 1. Now we have to create our physics component. So the first thing we're going to want to do actually is to check to see if physics is enabled. Okay, so if we open up our script system up here in core script or systems, scripting system, and we go down, I believe I made a function in the core globals to check to see if our physics is enabled. Yeah, right here. So is physics enabled? So we don't want to add in a physics component if we're not actually using physics, because by the way that the engine is right now, you can actually add in your own physics. You don't have to use the Box2D stuff. You can add all just Lua scripts that can control it. So let's take this function here and go, if is physics enabled, then now we're going to want to add in our physics component. If Box2D is enabled, create a physics component. Okay, so that's in here, to do. So if you take a look at our GitHub repo right here, I do have a link to the docs that I've been making. I've been making documentation for our engine, and it's still a work in progress. There's still lots of stuff to do. We can show different ways to do the different functions. I have little examples on how to do it, what things are, what we need to add. I'm definitely missing stuff, but I'm going to be adding more stuff in. So the first thing we're actually going to need to do is create a physics attribute object for our new physics component. And this is all the properties for that object. And we're going to do that right now. So we can actually just copy this here, and let's just copy the whole thing. Okay, we're not going to need all that stuff, but we'll go over that when we get to it. So let's put this here and just paste that in. Okay, so we're creating our physics attributes. Because this is a collider, we actually don't want it to be dynamic. I want it to be static. And it should be static like this. Let's make it 1,000, but it's static, so it doesn't really matter. We can get rid of these comments. Unless you want to keep them in, it's up to you. Get rid of these, get rid of these. Let's put the friction to 0 and the restitution for 0. Let's get rid of this. We don't need the radius because it's not going to be a circle. And the gravity scale can just be set to 0. We don't want gravity to have any effect. Get rid of that. And the position, we actually just want it to be transform.position, and that can stay. Get rid of that. The scale, it can just get rid of it because it can just be 1. And circle, it's not a circle. And circle defaults is false. Fixed rotation, we want that to be true. We don't want to allow rotation. And now we're going to have to add in our box size. So let's just copy this down a line and just say box size is equal to vec2. And that's going to be the tile set dot tile width and the tile set dot tile height. Cool. And then we're also going to need, if we go back to the docs, we have b box shape. So it uses the box size upon creation. Okay. If that flag is not set, then it won't use this box size. It'll just ignore it. So we can just copy this down, and this will be true. But it's true by default. I will add that to the docs later on. Okay. So that's our physics attributes for that. And so all we need to do now is go tile, add component, and then it's physics comp. I think I just called it physics comp. Let's just make sure. So if I go here and go to our ECS components and go to physics component down here. Yeah, see, I called it physics comp. Cool. And the physics comp constructor just takes in the attributes, the physics attributes that we just created. So let's go back into our utilities.lua and pass in our physics attributes. Cool. And that should create it for us. And we will just, let's actually just put this at the bottom. And we'll just put that there for now. And let's just run this to make sure that it works for us. Okay, so we have some errors. 226 transform. So it doesn't know what the transform is. That's because I never grabbed the transform. So we need to actually make a local copy of the transform. And that should work for us. Awesome. So it's not showing the colliders right now. Are we not rendering them? So let's go to our render shape system. And we already have this here, the render colliders enabled. So let's go and take a look at this. So that's why. So right now we don't have it enabled. So let's add in a little function that allows us to turn that on and off. Okay, because by default, this should be false. So let's go to our core engine. Yeah, so by default, we're not rendering our colliders. Okay, so let's go to our script system. And right here, so we have our physics stuff. So physics enable functions. We want to do the same thing for the render colliders. So render colliders functions. Cool. And we're going to do the same thing, lua.set function, and we'll say disable render colliders. Very verbose. You can use a different name if you like. Capture the engine, and all we're doing here is saying engine, not return, sorry, engine dot disable collider render. Copy this down, and this will be enable. Change this to enable. And copy it down again, and then this one will be render colliders enabled. This will be a return, and then is render colliders enabled. Sorry. Cool, and that should work for us. We should be able to take this function here, all three of these, and inside of our main, let's create a little function here. So let's go. Actually, we can make that in the utilities. So in utilities, let's just go to the bottom, and we'll say function, and then it'll just be like debug. We'll just say debug. Then we can use our keyboard. So let's say if keyboard dot just pressed, and let's say just key C, then we want to check to see if the colliders are enabled, then we're going to want to disable. So disable, let's actually go back and just grab that right from the script so we know what it is. So disable render colliders, go back to our utilities, else we want to enable. Now, when it comes to functions like this, it would make sense to add like a prefix like SC or S2D to it, so you know that this is coming from the engine. I'll make changes to that later, but for now, we'll just leave it as is. And cool. And then we just take this debug and put that into our update function here, and just put debug. Doesn't matter where it is; it can be down here. Add more stuff in. Then we'll just run it, and we should be able to turn on and off our colliders. Alright, so if I go, let's make it big, you can see, yay! So it loaded all our colliders for us. So we now have physics colliders for the platforms, the walls, and everything. Okay? Cool. Now it's drawing these triggers down here, because we didn't prevent it from drawing the triggers here. You can see here I'm showing the light green. We go back to tiles, and we show our triggers. That's what these are here. The light green is just the trigger. We don't want it to do that. We want to be able to control that ourselves. Okay, so let's go back into our engine here. Close that down. Go back into utilities. So that's one more thing we have to do. Okay, so up here, we are adding this here. So right here where it says tile set name is equal to collider, we will say, instead of ending here, we'll say else if tile set name is equal to trigger. Cool. Then we'll do stuff here. Okay. It's also going to need a collider. Okay. But these will be different. Or we can just say it like this. Actually, yeah, I think that would be even better. Let's get rid of this here. Okay. Okay. And then we go up here and say, or tile set dot name is equal to trigger. Then, and it still needs a box collider. However, if it's a trigger, we want to change something in our physics attributes. So right here we say if tile set dot name is equal to trigger, then we want to say our physics attributes dot be sensor is equal to true. I believe that's what we called it. Let's check our docs. Physics. So it looks like I didn't add that to the docs. we're missing that actual physics component. If it's not in the docs, if you have the master or the most recent master, it should be there. So if we check in our physics component, we should have already opened that up. See, like it's not even there. So we need to add that in. So it looks like I didn't even add that in yet. So in our components, let's go to our physics.h and our attributes. Yeah, so there's nothing here. See if it's a sensor or not. So we just put in a B is sensor. False. And let's add this in, physics component.cpp. We need to add this in here as well. B is sensor. We'll just actually just call it B sensor. I think that's better. Put a comma here. Cool. So that's bound there. However, we need to actually use that. So in our initialization function, right down here, when it's a fixture, we actually want to go fixture def dot be or is sensor is equal to m initial attributes dot be is sensor. Cool. And if we go down here, yeah, I guess we'll say is sensor here as well. B is sensor. And then we'll go back into our utilities and say B is sensor is true. And we have it defaulting to false. So if we go back to up here, it defaults to false. So you're not a sensor by default. Okay. So if it's a sensor or a trigger, add component, physics component, same thing. Okay. So now it shouldn't draw the trigger component. Let's run this again. Awesome. Yep. So now it's just running them as red because it's a collider and it's a shape. And that's the color that we put into the shape. However, we can filter that out. Okay. So let's go close this. And we'll go into our render shape system. And down here, because it's a box, see how we're adding our color in here? Well, we can adjust this, right? So we can say, we can take this and go auto color is equal to this. Send in a color. Okay. And then we can go, are we sending in the registry or are we using the M registry? All right. So if we go M registry dot get the actual registry and then go all of, and we want to say physics component and send in the entity. What did we call the entity? We just called it entity. Good. So just send in the entity. Say if and it doesn't know what a physics component is, so we have to come up here and add that in. Physics component. So if it's a physics component, let's get that physics component. So auto reference, let's say physics is equal to M registry dot get registry dot get physics component, and that's the entity. We're getting physics component, then we want to say physics dot is sensor. Okay, so if physics dot is sensor, then we want to adjust our color, and we'll make that to green. 0, 2, 5. Cool. Now we don't have this is sensor function, so we're going to have to create that. Go back to physics component right here, and we'll create the bool is sensor, and we're going to say const bool is sensor const, and build this. First thing we're going to do is check to see if not MP rigid body. I think that's what we called it. No. And why is this being a pain? That's why. So if we don't actually have a rigid body right now, or the rigid body's null pointer, just return false. And then we'll say return MP rigid body get fixture list is sensor. Cool. Let's run this again. Now it should come back as we are a sensor. It is true, and we should be green for our triggers. All right, there we go. Open this up and hit C. Awesome. There's our triggers. There's our box sliders. Awesome. Looking good. So it's partway done. So we see we have the rain. This is the same rain that we had previously. So we need to we can make some changes to the rain. But we can actually just leave that for now. That's fine. So now we need to make a little player to move around. So let's go back into main. We're just going to do it all in main for now. As we continue, we'll structure the game better. But for now, this is fine. So where are we playing our rain? So we're already setting this to channel 1. Let's set the volume of this. Let's lower it to 30. And that'll be channel 1. Get rid of the rain. Set. Cool. So before we get the player moving around, let's create something that I'm calling the dimmer. So if you saw from before, from previous, we had it was dark and the rain, and then everything was flashing and stuff. So let's create that right now. We'll just call it the dimmer. Create dimmer and lightning. Lightning. All right. So that's just going to be an entity. It's just be local, and we'll just call this the darkness. Darkness is equal to just an entity, no tag, no name, or no group. And we'll say darkness, add component. And it's just going to be our transform component. And it's a vec2. And it's going to be 0, 0, not 99, 0, 0. And now we need to get the scale. So the scale is actually going to be the window width divided by 16, because that's going to be the sprite, divided by 16, and the window height divided by 16. That'll be our scale, and we want 0 for rotation. Now, we should have these window width and window height functions. Let's just make sure, and we get that from the engine. So scripting system, window width, window height. Cool. And those should be set already. Right now, I believe we're just defaulting them to 640/480. That's our default values, and that's fine for now. Cool. So now we're going to need to get another sprite. I don't know if I added that sprite in yet. So let's take a look down here in our textures, blah, 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 blah. No. So I just have something I call a white box. All right. So I loaded it in. And if we just refresh our textures. So I just added this in. It's just a white box. If I open up the white box, all it is a 16 by 16 white box. That's all it is. Because it's white, I can change the color wheel of it. I can mess around with it. Okay. So now that we have that, we need to load that in. So let's go to our asset defs and then just add, let's call it white, and then white box. Cool. And let's go back to main. And we're going to add our sprite. So local, and we'll just say dark sprite equal to darkness. Even though it's white, you'll see. We'll be changing the color of it. Darkness, add component. It's going to be our sprite component. And it's going to be the white box. And that's just 16 by 16, 0, 0. And let's put it at layer 4 for now. 0 and 0 is your start X and start Y, and 4 is our layer. Then we want to set the color. So you go dark, bright dot color is equal to color. And we're going to set it just to black. So no color. And we want to set it to a 100 for transparency. And then we want to generate our UV. So we go with dark, sprite, generate UVs. And if we run this, it should have like a thin black layer across everything. There we go. So it looks like darkness now. Okay. Awesome. So let's close this down. So now that we have our darkness, we're going to need a way to update it. And since we already have this timer up here, let's just bring this timer down a little bit so we know what we're doing with it. Okay. So we have our timer. We can create a little function. And that's just going to be called, let's say, function update dimmer. Cool. And that's going to take in our entity, the darkness entity. Okay. Now this is just, it's not necessarily a hack per se, but this is just a way that we can change the colors of it and make it look like a little lightning style flash. So we can go local dark sprite is equal to entity get component. That's our sprite component. Once we have the sprite component, we can say if g timer, the elapsed ms is greater than, let's say, 33,000. Then now we want to change our dark sprite color. So dark sprite dot color. And we're just going to make it fully white. We're just going to flash white. That's the whole point here. 255, 255, 255. And let's say 25 for the transparency. So it's a little flash. And then we say end here. And then we want to go down. We want to do some more little checks. So we go if g timer dot elapsed milliseconds is greater than, let's say, 3100. So it's just like 100 milliseconds. And might as well keep this is less than 3200. Then we're going to change it back to black. Right, and then let's copy this whole line. So it's back to black, copy this whole line. So if it is now, let's make this else if timer is greater than 3200, but less than 3400. Let's change it back to white. Copy this, change it back to white, and then one more else if. Let's copy the whole line. And if it's greater than 3400, get rid of all that, just keep the then. And so we're going to do one more thing. We're going to change it back to black right here. And then reset both of our timers. G timer dot stop. And start it again. The timer dot start. Cool. That's it. That's all it's doing. So right now we're just doing a little flash. That's what it should be doing. And we can do that right down here. And we can say update dimmer and send in our darkness sprite. And if we run it, that should work unless we have some errors. Cool, so it's running. And let's see. Oh, awesome. See the nice flash there? That's what we were going for. Looks like our color didn't change back to black. Let me run this again. It starts out darker. Yeah, it's darker here. Because the transparency is not the same. So I actually want it 100 transparency when it's black, not 25. Try again. Nice, there we go. Cool. So let's close that. All right, so now that we got that, we got the dimmer. So now let's create our player. So create simple player. We won't worry about the sprite at first. First thing we're going to do is just get it moving around. Okay, so let's go G player. So just a global entity for now. And just say entity. So we're just creating another entity. Everything's basically an entity. And we'll call it player for the name, no group. And let's add in our player. So we'll just say local and we'll say player transform. And that's going to be equal to G player, add component, transform component. And where do I want to put it? So vec2, we actually want to put it at a specific position. So let's scroll this down. Let's open up tiled again. Take a little look. So in our situation right now, so hopefully you were able to make a nice map, but we need to get the position that we wanted. So I want to place him right here, okay? And that's going to be at, if you look down here in this corner, it shows which tile it's on. So right here is at 1 and 26. So 1 over and 26, okay? So 1 over would be 16, because these are 16 by 16 tiles. And then 26 times 16. Let's open up a calculator. And let's go 26 times 16. 416. Let's place them at 416. Cool. And scale is just going to be 1 to 1. Vec2, 1 to 1 for scale. And no rotation. So 0 for rotation. So now that we have our transform, now let's add in a collider. For the player, we want to give it a circle collider. Because the way that we're loading or creating the box colliders, let's just run this real fast. So right here, so the way that we're loading our box colliders, it looks like they're all together. However, they're all their own individual little squares, okay? So each square has little edges on the top. So instead of an entire platform, like later on when we're creating our own tile map editor, we'll just be able to drag a box the size that we want it to be without having to worry about individual tiles. We can add that in later. Well, eventually we'll get to that. But right now they're all individual blocks, and they all have their own little edges that they could get caught on. So in box 2D, the little edges could get caught. So when you're trying to slide it across, there's little things that can get caught on. However, as a ball, it just rolls over those edges. So that's why we're creating a circle collider for the flare. Okay? So we can go local circle collider is equal to G flare add component circle collider. Okay? And it's going to have a radius of 8. So half of the width. So now that we have our circle collider, we can create the physics attributes. So we want to create the physics component or attributes for the player. So we can say local player phys attributes is equal to physics attributes. Okay. Then we can say player physical attributes. Physics attributes, copy this whole thing, and then just say dot e type is equal to body type dot dynamic. We want this to be a dynamic body because we want to be able to control it. Okay, and then we'll say, let's just copy the whole line down and just change this to density, and we'll have this character be 75 kilograms, so 75.0. And then now let's do the friction. Our friction is going to be 1.0. Okay. Change this to friction, and then change this to restitution. Restitution. I'm only going to want this to be 0 because I don't want our player to be very bouncy. And then we can say player physics attributes dot position is equal to our player transform dot position. Okay. And then we can say, now we are going to say player physics attributes dot radius is equal to the circle collider dot radius. Okay. And then we actually now, because we're using a circle, we have to let it know that it is a circle. That's true. We also want this to have a fixed rotation. So we go player physics attributes dot b fixed rotation. See, it's true. Now we can simply just add in the physics component to the player. So add physics component to the player. And we can say G player add component physics comp, and that takes in our player physics attributes. Awesome. Okay, so before we do anything else, let's just make sure that it gets added into the place that we want it. Bang, I got an error. What did I do wrong? A big error, so let's go back and see. So main, oh, that was silly. Run that again. All right, so it doesn't show anything, but our guy should be there. So there's an issue. We have to figure out what that issue is. Why don't I see it? So what if I change my collider radius down to 1 and see? Still nothing. Okay, so let's keep that at 8. All right. So let's go back into our, I believe the problem's in our physics component. Okay. So see here, when we're doing our blocks, we're doing our pixels to meters, but we're not doing that in our circle shape. We need to do that as well. Let's copy that in, paste, and run it and see. Yay, there's our little ball, and it's exactly where we wanted it to be. All right, cool. All right, so let's go back into our main.lua, and let's create a new function so we can move our little ball around. So let's say function, and we'll just say update player for now, and that'll take in the player. We will structure this better and make states and stuff like that for our player to be in. But right now, this is just to get it going, get it working, okay? So the first thing we're going to want to do now, because we're using physics, we want to go local. We want to get the physics of the player. So local physics is equal to player dot get component, and we get our physics component. Okay, physics comp, and then we want to get the velocity. So local velocity is equal to physics get linear velocity. And the first thing I'm going to want to do actually is to stop the ball if we are not pressing the button. Okay, so we'll say physics and set linear velocity. And then we're going to say vec2 because this takes in a vec2. And we're just going to stop the xy movement, or no, the horizontal movement, sorry. And we'll say, well, we want the velocity to keep going. So if the ball is dropping, we want it to keep going. We want it to keep going at the same velocity that it was already moving at. Okay. And then we can say, now we want to get the ball to move around based on our key presses. So we can just say if keyboard dot press key A, then else if, copy that, and then D, and here we're going to want to set our physics set linear velocity vec2, and we'll just say 10 for now, and then say velocity dot y, and we'll copy this, place it in here, and just say -10. We'll just say move ball left or right, or let's change that from ball to move player. It's not always going to be a ball. So move player, stop the player. Cool. All right. Make the player jump. That's what we want to do here. And for this, we're going to do the same thing with the keyboard. Okay. But we only want to do it on just press, not while it's pressed. So just press P, W. So when we press the W key, we want it to jump. Okay. And to make it jump, we're going to want to actually do a linear impulse. So we want to go physics, set linear velocity. First, I want to set the velocity vec2 to the x velocity and 0. Because the way that linear impulses work in Box 2D, they add to each other, or they accumulate if you do multiple impulses. So we actually want to set the linear velocity of y to 0 and then do our impulse. So physics dot linear impulse. And we say vec2 is just our velocity dot x. And I think it's -1000. Let's see how that looks. And let's just run it. And we can't see our ball, okay, so it's not moving. You know why? You guys already knew this, because we actually aren't updating it. We created a function, but we're not doing anything with it. And it won't work unless we're updating it. Let's do that here. Actually, the dimmer and the range generation doesn't really matter. It can go after everything else. Okay. And that takes in our G player. Let's run it. All right. Cool. Oh, so our movement is backwards. Right now I can just keep jumping. You see how we drop slowly? So we're going to have to change a few things. So yeah, right now my movement is backwards. So let's change that. So let's go back into our function here and just adjust this. So this will be 10 and this will be -10. You guys probably already taught that as well. And let's print our velocity so you can just see what it's doing. So print velocity dot y. And if we print this, as you can see, so as we're idle, we're only at 0. So our velocity is 0. And if we jump, see it goes into the negatives. Negatives on the way up, positives on the way down, negatives on the way up, positives on the way down. Cool, that's what I want to know. But what I do is here now, we just get rid of this for now. We can say if velocity.y is less than 0, then we're going to want to set our physics dot set gravity scale, and we'll set it to 2. Else, if, let's copy that. Move this up. If it is greater than 0, that means we're on the way down. I actually want it to fall faster. Let's copy this and change this to 5. So our scale is 5. Okay. And let's run it now and see. So move, jump. See how she falls faster on the way down? So our jump's not really high enough on the first jump, but it's looking pretty good. But you can keep jumping forever. There's nothing stopping us from jumping all the way to the top. Cool. All right. And let's change this to 1250. Play with these numbers as much as possible to get a little feel for it. All right. Make it bigger. So that jumps a bit better. Oh yeah, much better. So you end up with a nice double jump. So that's another problem. When you hit the corners, you still bounce a bit. Yeah, see that? It's a bounce off the corner. So that's okay. Cool. All right. Very nice. All right. So now that we're able to move the player around, it's just a ball right now. Let's actually create a follow camera that will follow us around. It'll follow the player and it'll stop at specific positions. Okay. So let's first get the camera. Or actually, we don't even need to get the camera. Let's just say camera dot get, and then set scale, and scale will set it to 2. Let's just make sure that that works. Yep. So see we're at 2 right now. So let's put that here. Create a follow camera for the player, and we'll just say G follow cam is equal to follow camera, and we need our follow cam params, follow cam params. And if you remember from before, we set this up that it can just take a sole table or a Lua table, and we'll set our min x, mix x, min x is equal to 0. Min y is equal to 0. Max x is equal to 640, because that's the size of this map. Max x, or max y, is equal to 480. Okay? And then we'll also set the scale to 2. So once we have that, we now have to send it into the player as well. Follow cam params, this needs to be here, and G player. So it needs to know what it's following around. Let's make sure that works. First thing, so we'll update our player and then update our cam. So we'll say G follow cam, update. Cool. Awesome. Our camera's following our guy around. Perfect. And see how it stops? It doesn't keep going. It stops at our boundaries that we set for it. That was the goal. Cool. Look at that. Perfect. We got our ball. Nice little level going. Awesome. Doing pretty good. Making good time. All right. Now let's add in the player sprite. You can grab any sprites and stuff off of Open Game Art. I highly recommend Open Game Art. However, I have my own sprite that I've been using for the last game jam I was in. And that is this player sprite. I just added it in. So if we refresh right here, our player sprite, and I'll open that right up so you guys can see what it is. So it's just this sprite has some different, so this is idle. This is running to the right. This is running to the left. There's the throwing animation, and then there's also a jump and fall animation. Okay. or a jump animation. I don't think the fall animation is in there at the moment. So that's the one that we're going to be using for this particular one. I recommend going to Open Game Art to grab one. So if you just go to Open Game Art, you can grab anything here. So go browser, search, and just say platformer 2D art. I like to do CCO, so you get some stuff that's in the public domain. And just grab any, like right here, Classic Hero. This will work. Anything like that will work. So Open Game Art is a great resource, and I highly recommend you use it. So let's go back, and let's add in our sprite. All right, so up here, we'll just add that in up at the top. Before our physics, we'll add in our sprite. Actually, we'll do it right here. So we can go local sprite is equal to G player, and add component sprite, and it's going to take in the, we're going to call it just a player. I haven't added, we have to add it into the asset def still. Then I know these are 32 by 32 tiles. Zero, start at 0, and we want to have this at layer 2. Okay. Then we want to go sprite, generate UVs. Cool. Let's quickly go into our asset defs and add that player in, or I'll forget. And I think it's player sprite, and we just want to call it player. Let's take a look again just to make sure. Yeah, player sprite. If we double click on this, this will open it up as well. Yeah, there it is. Cool. So we're adding in our player. If we just run this, it should show the player now. Awesome. So as you see, the collider is in the top left corner of the player. So we're going to have to adjust that. Okay. And the only way that we can do that is to add an offset. Let's take a look at our circle collider. Up here, components, circle collider. So it does have an offset already. Okay, let's go into here. And we already have a constructor to add in the offset. That's exactly what we need. Okay, so we're going to go back into our main.lua. And right here for our circle collider, now we not only need the radius, we need a vec2 for the offset. And let's start that at 10 and 16 and see where that is. Okay, so it didn't like that because I forgot to add in a bracket. Run it again. All right. Dang, that looks nice. The slider still needs to be moved over a bit, not really center, but it looks much better. Cool. All right. So let's move this over again. Let's change this to 8. See how that looks. Awesome. I like that. That looks great. Cool. Close it. All right. So now that we have the sprite, we have the collider. Now let's add an animation component. So local. Actually, we don't need to grab the animation component, but we'll just say G player add component animation. Now this one has 6. I wanted to go at 12. So it has 6 frames. I wanted the frame rate to be 12, and I wanted to have an offset of 0. And this is a horizontal, so we want to say false here, and then true for looping. So if we run it right now, the first animation should just be eyes blinking. Yeah, you can see how the eyes are just blinking there. When we move it, it's still just going to do the eyes blink because we have to adjust the position in our sprite component. So our start X and our start Y are UV positions. So that's what it's looking for. So we need to be able to adjust those. So we'll do that down here in our update player. The first thing we want to do now is grab the local sprite. And that's equal to player get component sprite component. So now that we have the sprite, we can adjust the animation, which animation we're showing. Now I'm going to do a little hack here and just create a little B left. So are we facing left? Eventually we won't have to use that. That's what we're going to use for now to show. And what we're going to do here is down here inside it. So when we push the key A, we're going to want to set B left is equal to true. So now we are facing left. I'm going to say sprite dot start y is equal to 3. Let's go actually to our sprite just to verify right here. So when we're actually pushing the button, it's going to be 0, 1, 2, 3. So this is run left, okay? Minimize it again. And we can just copy these and here, paste. This will be false. And then change this to 2, okay? And we're going to do another one right down here. So right after the jump, actually, let's do it right here. We're going to say if velocity dot x is equal to 0.0, then, and we're going to want to check to see, are we facing left? So if B left, then sprite dot start y is equal to 1, else sprite dot start y is equal to 0. And cool. So what this will do is reset back to idle animation. And now we have to set our sprite UVs. So if we open up our sprite component right here, sprite component, we have our UVs. So we have our U, our V, UV width, and UV height. But we need to set those again. So let's go back into main again, and we'll say sprite dot UVs. Is that what we called it? Hold on. Back into sprite component. What do our bindings called it? UVs, yep. So if you remember, UVs are just your X and Y, where V is equal to your Y. Is equal to sprite dot start Y times sprite dot UVs dot UV height. And let's run it. Awesome, we're running. And we jump. We don't have the jump animation in there, and that's fine. Jump, jump. Just running. Look at that. Perfect. That's exactly what we were going for this video. So now we have some music, the music that you heard at the beginning of the video. Let's add that in. And I got that also from OpenGameArt. Go into OpenGameArt. I already have the link. You can just paste that in. It's called Snowfall right here. Now this is a CCO song. You can download it. I've already downloaded it myself. I've changed the name to just be Snowfall. It says that you don't have to credit, but I do recommend you credit Kistel or Kistel. Okay. Down. And let's go in here. And let's go to where our music is, or our sound, sorry. Where is our sound? Right here. And then we're going to want to have our music dot play. And I want to play the Snowfall. And I'm going to want to play it. I want to loop. Remember, the music has its own channel. And we want to set the volume of the music to 50%. Now we haven't added this in yet, so we still have to add it in. So I've added that in, and if we go to our editor, assets, and in our sound effects, we have it called snowfall.ogg. We need to actually add that into our asset devs here in music. Let's just copy this here. Snowfall. Snowfall.ogg. Cool. And if we run it, it should play the music as well. All right. Cool. All right, awesome. There we go. So that's basically it for this video. Now we got a player moving around, we can run around, we're loading in maps that we created in Tile, creating the colliders based off of our load map utility function. And we have some lightning and some rain going. The rain does look a little bit big, but we can actually change that. You see how it's splashing in midair? Because the way that I created it was only set up for top-down games. But if we go into it right now and take a little look here in our rain generator.lua and the scripts, rain generator.lua, there's a few things that we're not sending in. Right now, we don't really care about the scale and that. So if our rain, let's add that in right here. Actually, let's do that right here. And scale is equal to 1, or params.scale or 1. Okay, take our m scale. And instead of sending in 1, 1 here, we can send in m scale, this dot m scale, this dot m scale. And we also need to go down into our rain generator. We need to add it in down here as well. Okay, so we're not sending in any scale. We need to add that in. M scale is equal to params.m scale, or params.scale, sorry, or 1. And then once we have our scale here, when we're generating our rain, this dot generate, we can go down here and set the scale in here on our create. So we'll put a comma, go to scale is equal to self.m here. All right. Okay, that should still run. We haven't made any changes yet, so it should run. Yes, but everything's the same. The only problem is on our update, we're not taking into effect that I don't want it to splash. So for now, we're just going to do a quick hack rather than adding in more stuff. So right here, let's change the number of frames. Because we're doing num frames -1, right? We need to change the number of frames to 1. So when we're creating it, num frames is 1, or num frames are 5. So when we're creating it down here, actually we don't have to hack it. We can just put it in here and go num frames is equal to 1 for now. Just put it there for now for 1, and it should just be the 1. Awesome. See how we're not splashing anymore? Cool, that works. But I also want to change the scale. So right before we're doing our generation, let's go into main here. Rain generator, we have our create, and we can just put in a table and say scale is equal to 0.5. And it should be half the size now. Smaller raindrop. We open this up. Awesome. Looks much better. There we go. All right, so that's it for this video. In the next video, you see here, if we fall down, bang, see how that's a sensor? We just go right through. Now we need to get into our contact listener. So we're gonna have to be creating user data so when we touch this, there's something that we have to do with it. So we take the information, and so say we have to kill our sprite or whatever. We'll get into that into the next video. The contact listener, and that is going to take a while to explain. There's a lot of stuff that we have to do in the engine to get it to work correctly. Because if we were just using it in C++, it'd be fine. The problem is we want to be able to script it through Lua. So we need to be able to create those bindings and the meta reflections using ENTT meta. So we'll get into that in the next video. Hopefully you were able to get this going the way that it is now. Hopefully you enjoyed it. If you have any comments or questions, concerns, please leave them below, and I'll make sure I'll get back to them and give them an answer if I can. Also, please like and subscribe if you haven't done so already. All right, that's it. Take it easy.